Well, hello Internet, and welcome to part 3 of my statistics tutorial. In this part, we're going to continue with the real-world example we worked in part 2. And what I want to start off here first with is I'm going to create functions to calculate standard deviation as well as the coefficient variation. Okay, if you remember from previous videos, I talked about variance, and variance is important when calculating standard deviation, of course, and variance is basically just going to tell us how our data is spread around the mean. Standard deviation, because the values with variance are squared, as you can see right here, we go and sum all these values and square them. Well, because of that, the variance is going to give extra weight to outliers, which we do not want. And to get rid of that and to calculate standard deviation, all that we need to do is go and find the square root of the variance. So let's come in here and let's create a function that is going to take our data and find the standard deviation. So I'm going to go define get standard deviation. And it is going to receive, again, a dictionary that is going to have keys and values representing what we are searching for. I'm going to create a dictionary here, and it's going to hold the key and the standard deviation for each of our items. Then I'm going to cycle through all of my keys that are inside of the data dictionary, and to do that, I go keys like this. And then I can go and store them again with the same key. And then I'm going to call our standard deviation function in our little module that we have created with all our functions in them. And I'm going to have to pass in the data dictionary with the key. Then after I do that, for every single one of the keys, I get the standard deviation for every single item. I return that new dictionary. And now let's go take a look at our statistics module, which we've been working with. And if we look at standard deviation, you can see right here, we are calling the variance function. And if we come up inside of the variance function, we see a potential problem. That problem is going to be what happens if the length of the number of arguments sent in here is equal to 1. Well, that's obviously going to be a division by 0 error, so we want to fix that. So what we're going to do here is we are going to say try, and I'm going to call this answer is equal to numerator and denominator. And if we get in a situation in which we try to perform that calculation and get an exception, we're going to say except. That exception is going to be the 0 division error. And in that situation, we will say answer is equal to the numerator divided by 1, which is going to make those stand out, but we will notice it. And there we go. So that's going to correct a potential problem because we're not dealing with a whole lot of data here. So normally you'd be dealing with thousands and thousands of pieces of data. But in this situation where we're not, that could be a potential problem. So now it's solved. So now we can jump back over here. And you know what? I think I also want to go in here and create our coefficient variation function as well. Now, if you don't remember, the correlation coefficient is going to adjust our covariance to see relationships between two pieces of data. In our example we used here, we compared market cap to earnings, and then we wanted to see if they were going in the same direction. Well, what we want to do now is take a look at whatever piece of data we are analyzing versus profits, and see how much influence those individual pieces of data have on our overall changes in profits. Valuable, extremely valuable pieces of information. And I'm going to go over here and write up the code for it. And you're going to notice that we're going to do a lot of the same things here because we have our code set up pretty well. All right, one thing that we're going to need to do, however, is we're going to have to change this to coefficient variation, and spell that correctly. And we're also going to create a dictionary, and we're just going to come in here and basically do exactly the same thing. We're going to get all the keys from the data dictionary passed inside, and then we're going to perform our calculations on all those pieces of data. So this is going to be changed to CV, and this is also going to be changed to CV. Down here, we're going to have coefficient variation. We're going to call that function instead of standard deviation on each piece of data in the dictionary. And aside from that, that's all we need to do. So that's pretty cool stuff. Now what I want to do is down here where we have get mean profit data, well now we probably should change that from get mean because we're getting so much more data, but we won't. We'll just leave it like this here for now. And what I want to do is go in and put in our additional information. So I'm going to get my variance. So I'm going to say print F and title that's passed in here and go standard deviation and calculate that. And we're going to do basically the same type of thing. We're going to say that we want to call get standard deviation. And then inside of it, we're going to get this guy right here, get key profit list, all of that data, and copy that and paste that inside of here. And boom, now we can go and get our standard deviation barely without even changing our code, which is really cool. And then we can also get the coefficient variation pretty much in exactly the same way. So paste that in there. And just change this to coefficient variation, and then change this to get coefficient variation. We can come up here and just copy this if we'd like, and then come down here, get, instead of standard deviation, coefficient variation. All right, good stuff. And now if we come in here and run this program, and you can see that we're now getting the standard deviation, the coefficient variation. The only problem is that the spacing's a little bit off, so let's come in here and fix that. Let's go and get this new line out of here, and let's paste it down there instead. Run it again. And if we run it, you can see all of this beautiful data that we have here now. We can see how spread apart all of the different purchases by males and females are. You can also see how dramatically the different changes, whether a male, we were selling to a male or female, would lead to different profits. You can see how dramatic that is. And then our goal here is really to look for those specific things in the coefficient variation that gives us the highest correlation between profits and whatever the piece of data is. All right, so that is some good stuff. But I promised you previously that I was going to show you how to work with ranges, and so now I shall. Okay, so very often it makes a lot more sense to categorize different customers based off of range of ages versus just 43 and 26 and 37 and random all over the place. So that's what I want to do now is create a function or create a couple functions that allow us to analyze the age data based off of ranges. So what I want to do here first is I want to get the index that I'm searching for inside of our CSV file, along with an array with the array steps from first max on up. So for example, if they send us an array that has 10, 20, and 30 inside of it, what I want them to do is to grab the ranges of 0 through 10, and then it would be 11 through 20, and then 21 through 30. Okay, so they're going to say 10, 20, 30 is what they're going to send to us, and I'm automatically going to create these ranges and create customized keys with customized names based off those ranges. So let's do it. So I'm going to go define get range data, and it's going to give me an index, and it's also going to give me a max range list, which is what I just showed you. And I'm going to go and create all kinds of stuff from that. So I'm going to create a range dictionary, and it's going to have dynamically created keys that define the ranges that I want to grab. So to be more specific, let's say they sent us a array and it had 29 and 39 inside of it. Well, it's automatically going to make keys that is going to be range 0 underscore 29, and another one that is range and 30 and 39. So the data, the key name is actually going to represent what type of data is inside of it, which is really cool. So I'm going to go and define range index be equal to 0. Then I'm going to go for I in range 0 through the length of our maximum range list. And again, this is going just to define the maximum value for each of our range keys and all this other stuff. So then what I got to do is go range key is going to be equal to, and remember I had RNG underscore, and then this is the creation of my string that I'm creating. I'm going to go string range index, going to start at 0, and then plus, and then I'm going to have another underscore inside of there, and string, and I want to get the maximum range that they sent us inside of the list that they sent us, which is going to be in each of those positions. So all I'm doing here is creating key names that make sense based off of what types of information they're sending us. And this is range underscore key. All right, so now I have that. So now I can go range and dictionary and use my range key name that I just created. And I'm going to go and give it a value of 0. And then I'm going to say that I need to increment my range index, and I need to convert this into an integer, and then I get the next maximum range list item and increment this. All right, and it's going to give us some cool stuff. Whoops, accidentally jumped into some weird world. All right, so there we go. Okay, so after we've created all those key names, then I want to cycle through the dictionary keys and get the high and low range. So I'll go for key in range underscore dictionary, and for each of the keys, and then I'm going to say range list, and I'm going to go and get the key name in the key name, and then split it based off of underscores. So now I can get all those ranges, and then I know what to search for. Key and split, and then I get the low range value, which is in the range list 1, and then I'm going to get the high range value also. High range, and that is going to be in the second, or the third actually. All right, so I got all that stuff. Now what I want to do is cycle through the data in this supplied index and search for matches inside my range that are defined in the dictionary keys. So I'll say for I in range 1, and we're going to go and get the length of sales data, of course. And I'll say if integer low range, there it is, or less than, and then I'll go int and sales data I, and whatever the index is they supplied, which is going to be in reference to age, of course, less than or equal to, and again change this into high range. All right, so if we have a situation in which we have a value inside of that range, well, in that situation I know I can add it to my range dictionary. So range dictionary with the key that we're currently cycling through, and increment it by 1. All right, and that's going to count up all of the ages inside the different ranges we have. And then after I do all of that stuff, I can jump out of here and return my range dictionary, which is going to be super cool and very, very useful. Okay, so what else do I want to do? Well, why don't we test it out? So I'm going to go and create a list, and it is going to contain 29, 39, 49, and 80. So those are going to make, this is going to be 0 to 29, this is going to be 30 to 39, and I think you get the point. Then I'm going to create an age dictionary, and I'm going to go get range data, and I'm looking for index 4, and I need to pass in my list so that we know all of the ranges to work with. And then I can say print age dictionary. And if I did it, you can see we have 4 people, 4 customers between the ages of 0 and 29. We have 5 between the ages of 30 and 39, and so forth and so on. Look at that. Pretty sweet stuff. All right, good. So now what I want to do is I want to get my range profit list. So create another function, and I'm just going to call it get range and profit list, and I'm going to pass in our index and a data dictionary. I'm going to have to create a profit dictionary that's going to hold all the profits for all the different ages. Then I'm going to cycle through my keys that I have in data dictionary keys. I'm going to create a dictionary key with a list. So profit dictionary, and it's going to have the key inside of it. And this will be empty. And then I'm going to get my range data that's going to be used to search inside of sales data. So this is going to be range list is equal to, again, I'm going to split on the underscores. And I think you gather how those are all set up. So underscore. And then I can get my low range and my high range just by going range and list and get the second item out of there. And then to get the high range, I go and get the third item out, which is an index 2. And now let's go for I in range from 1 through the number of sales data items. And I'll say if, and I have to convert this into an int. Again, we're going to go low range less than int. And here we'll be pulling out sales data and I and the index, which is going to be specific to age, is, less than or equal to, and our high range. And there it is. And if we get a match, I want to add the profit to the list in the dictionary that is specific to the age range. So I'm going to go profit, dictionary, and set default. And I'm going to append to the array by going append, convert this into a float, and get my sales data, I, and 13. 13 is the index inside of our sales data list that has all of the profit information inside of it. And then after I do all of that, I can return my profit dictionary, which is going to have all of the awesome stuff in it. Okay, let's continue on here. So what I want to do now is go and get my range profit mean dictionary. So I'm going to call this define get range profit and mean category dictionary. Kind of long-winded, isn't it? All right, so go index and data dictionary, and then we can go and create our dictionary. I'm going to call this profit mean dictionary, which is going to be empty, of course. And then I need to create a dictionary with the key and the mean values this time for each category. So I'll say for key in data dictionary keys. So each one of those items. And then I can go and create my dictionary key from my list. So I'll go profit mean dictionary and key, and so that's where everything's going to go. I'm going to get my range data. So why don't I just copy this up here instead of typing it out again. So I'm just going to copy this and paste it inside of there, and split and low range, high range, and all of that good stuff. And I can copy this as well. So let's copy it. So let's copy that and let's paste it inside of there. And if we have a match with this if conditional, we just add our profit to the list in the dictionary. So profit mean dictionary and set default and key, and then append, convert this to a float with sales data, I and 13. And then outside of here, I want to get my mean, get the mean of the list and store the mean of the list instead of the list inside of the associated dictionary. So profit mean dictionary is, and key is going to be equal to, and then I call stats, and then I call mean, and then pass in my profit mean dictionary with the specific key. And then after I do all of that, let's see here. It's one problem with using gigantic characters. Sometimes it's hard to say how things are lined up, but I think I got everything here now. So then I can go return and profit mean dictionary. And then we can test everything here to see if it's working, and we can now work with ranges. So I'm going to say print and get range profit list, and I'll pass in 4 and my age dictionary. And then I'm also going to go and get my mean for the different age ranges. Get range, profit, mean, category, dictionary. Again, that's 4, and age dictionary is what I'm going to use here. And when I run it, you can see that now not only do we know how many different people are in the different age ranges, we also got a list of profits for each of the age ranges, and we also have a mean for each of the age ranges. And who is the most profitable age range? That would be people between the ages of 50 and 80. And remember, that's a mean, so that's an average profit. And there you go. Now you can work with ranges. Now you can do standard deviation and coefficient variations and so much more. If you have any trouble, all of the code is in the resources directory. Compare the code I provide there to any error code that you have. A website that I recommend is diffnow, DIFFNOW.com. It's free, of course. And like always, please leave your questions and comments down below. Otherwise, till next time.